says the marginal cost of producing the X box of DVDs is this formula here, this 9.
Oh, wait. I had a question on this problem. I wrote down like why I put it in here. So for the C, so the C is 100,000, right?
Yes.
Is that like a consistent thing? Like if there's a fixed cost, that's the C?
Not always, but based on this function it is. So if you were to get this problem again, it would be.
Okay.
If you were to
How do
get
I
if
know?
like
How do I know if it's not? Because I also have number 7 kind of does the same thing, where they give you like the C, but I just can't differ. I don't know how to differentiate like if another problem. You know what I mean?
yeah. Um, Let me, of course, timing of this is awful. I have to just log back into this email account. So just let me get to where
Okay.
I can see that problem with that you're talking about again. It happens once a week, and it happened right now.
Okay.
Okay. It depends on the function. So what this fixed cost means is that the cost of 0 is 100,000. So if the rest of the function after you integrate it is 0, then it's then it is just C, like it becomes that. Um, Almost log back in here where I can tell you, look at the other problems and tell you. So you said question 7 is similar.
Yeah.
Uh, okay, so this one, the fixed cost is this is another example of a function where it will be just that initial value. So the answer is yes. I mean, in these two problems, it is.
Okay.
But we can go through the steps to show you why, if you'd like.
Yeah.
Okay, I think because I think that'll be helpful because you got to show the work. So you've got to integrate 9 plus. I'm going to rewrite this as 1 over 70,000 times x squared dx. So you're integrating each of these so that this 9 becomes 9x. The 1 over 70,000 just comes with because it's a constant. And the x squared becomes 1/3 x cubed.
Isn't 1/70,000 a constant too, or no?
It is. So it comes because it's paired with the x squared though, it just comes down.
Okay.
Okay, so then there's this plus c, and then we can make just a little bit of a simplification here. This is 1 over 210,000 x cubed plus c, and that's the cost function. And I made a note earlier that c of 0 is according to this problem is 100,000. That's the fixed cost. And the reason it becomes c is because when you put 0 in for x, 9 times 0 plus 1 over 210,000 times 0 cubed plus c, both of these go away. This is 0, 9 times 0, 0, 0 cubed is 0. And that's why it becomes c, not because it's the fixed cost, but because it causes these things to cancel.
Okay. So I should just plug in 0 just to be safe.
Yes. Now,
Okay.
if you think you're going to get exactly this question on the test, you could, or the 7, which I'll snip in, you can most certainly do exactly what we just said, which is just plug it in for C. It will be exactly the same.
Okay.
All right. So this one is they're giving you a rate. This m of t is a rate, and that means you're going to integrate this m of t just like you integrated the previous problems. You're gonna find the antiderivative or the integral of this function here. And for each of these, it's power rule. For each of these power rules, so the minus 3.3 just comes with, and then the t squared, it becomes 1/3 t cubed plus, bring the 16 down, t becomes 1/2 t squared plus 280t plus c. Okay, and then you can simplify these coefficients. So 1/3 of minus 3.3 is minus 1.1 t cubed plus 8t squared plus 280t plus c. And this is your big M of t that you just found. That's what happens when you integrate here. It becomes this thing that you're trying to find. And then it tells you that M of 0 is 360. So that means when t equals 0, the y value is 360, or the output is 360. So that means we're going to put 0 in for t. So let me do that. So 360, so we're bringing this line down here. It's minus 1.1 times 0 cubed plus 8 times 0 squared plus 280 times 0 plus c. So like you said, you should just put 0 in. In this case, everything goes away. 0, 0, and 0. So c equals 360.
Okay.
I would always see. If this wasn't WebAssign, I would warn you, like, this only works some of the time, and your instructor could very easily give you an example that isn't like this. But because it's WebAssign, because you're probably going to get these same questions, yeah, I think it's okay to just make c equal to that value.
Okay.
Okay, so 26 is the next question that I see in order here. You said, oh, I'm sorry, 20. 20 is the next question. Okay. Yeah, this one is really odd, but it's very awkward.
Yeah, all I wrote in my notes about it was more practice.
Yeah. So first thing I think you should do here is use your calculator.
Okay.
And the reason is because if you know the target, maybe it'll help explain some of the steps in between. So that was the math 9, I think.
Okay.
So it'll be something. It'll be like 4x to the 1/3 power, dx integrated minus 3 to 3. You should get 0 when you do that. And I saw in another problem here that it looked like you entered an answer like e to the minus 13. Anything that's some number e to the minus 13, you want to make that 0. That's what that means. You don't want to enter in you don't want to enter in this is not good. You want to enter in 0. So if this becomes something that isn't 0 but it looks like this form, then it's 0. So let me know when you verified that, and then we'll talk about how to actually do it by hand to confirm that answer.
Okay. I'm doing it right now. Okay, yeah, it's 0.
Okay, so now, and the reason we do that, you always do that when there's these, this is a definite integral. Whenever you see these bounds, you should always do that just as kind of a check here. So now, this one is really weird. I agree. It's and the way I showed you before, maybe it was unnecessary, but I just kept it as it is. Now we could make a u substitution. Do you want to do this with a u substitution?
Okay. Yeah, that's fine.
Okay, so du equals 4 dx, and then you solve for dx. So dx equals du over 4. Okay, so then you take the integral, and without the bounds, we'll put those back in. It's the cube root. Now instead of 4x, you put in u. You always substitute for u, and for dx, du over 4. So this becomes the integral 1/4. And then the cube root of u is like saying u to the 1/3 power. So this is u to the 1/3 power du. Okay, so now this is something you can handle because it's you just bring the 1/4 down. This you have to add 1, so it's 1/3 plus 1 over 1/3 plus 1. And I'm writing the plus 1 because it's a fraction. Sometimes it just doesn't compute real well when it's like that. But they must have the same exponent. So now whenever you have a fraction on the bottom, this time you have 1 over 4/3, that equals the reciprocal of the fraction 3/4. So you have this 1/4 in front times the 3/4 from the 4/3 on the bottom, u to the 4/3, and that becomes 3 over 16, u to the 4/3, but you have to back substitute, and your u was 4x, and you want to put that back in here. So that's a 3 over 16, 4x to the 4/3 power. Okay, and then now this is where you evaluate from -3 to 3. You wait until the end. Wait to the end to do this. Okay, so it's always top minus bottom. So you put 3 into this equation. So it's 3 over 16, 12 to the 4/3 power minus, and then you put this -3 in here, and that becomes -12 to the 4/3 power. And now you could put this in your calculator, but you already know the answer is 0. So you just write 0, and you've shown your work, and everyone's happy.
Okay.
The only thing that will change for you if you do this problem are these bounds, but they'll be the same. Like you're going to get, it'll be -4 to 4, or -2 to 2. And this number right here, it might be 2, it might be 3, it might be 5, but it will produce the exact same thing.
Okay.
Same answer. And that's where you're getting a little bit of benefit of using WebAssign, because you can if you see this problem, the answer is 0.
Yeah.
If it's truly this. Okay. So now the next problem that you sent me, well, do you want one like this?
No, I think I got it.
Okay. Okay. So let's move to 26. Yes. Okay. All right. So calculate the total area of the region described. It's bounded by this curve, y equals 4 minus x squared. So just make sure. So 4 minus x squared looks, if you were to graph it, it looks like this. And that's -2 to 2. This one goes to 4, so there's a little bit more here for that. So there's this place. I'm sorry. Go ahead.
Should I graph it?
You probably should, but it's in the TI-83. It's just it's going to graph more than this. Like your graph's going to go on forever, but you need to know to cut it off there and there. Like that's what you want to see. So you generally figure out, where does y equals 4 minus x squared equals 0? Where does it equal? Where does it hit the x-axis? And you'll find that it's 2 places, 2 and -2. That's where I came up with those. So there's really these 2 regions. There's this region here above the axis, and then there's this region off to the right here, which is below the axis. And that's what it says when it says do not count area beneath the x-axis as negative. So you're going to find area 1, you're going to find area 2, and you're going to add area 1 plus area 2.
Okay.
We're going to use calculus to do that. Okay. So first thing is we're going to integrate.
Wait, why is it -2 or 2 to -2? Isn't it -2 to 4?
It is, but we're asking, where does this graph hit the x-axis?
Okay.
And it hits it there at 2, but it says we're going to 4,
Okay.
and that's why there's these 2 regions.
Okay.
So you have to figure out where it hits the axis, and then figure out where the other region will be.
Okay.
Okay, so to find region 1, we're going to integrate from -2 to 2, these 2 bounds here, 4 minus x squared. And these will always be where it hits the axis, dx. Okay, so we're going to do that first. So this is 4x minus 1/3 x cubed evaluated from -2 to 2. Now you can put this in your calculator as well. So you can always verify the answer that we're about to get, because you want some certainty that you're putting the right number in. So it's always top minus bottom. So in this case, it's 4 times 2 minus 1/3 2 cubed minus, and then I put a big parentheses here, 4 times -2 minus 1/3 times -2 cubed. So this 4 times 2 is 8. 2 cubed is 8 times 1/3 is -8/3. This is -8, but because of that, it becomes +8. This inside here is -8 times -1/3, that's +8/3, minus 8/3 there. So this becomes 16 minus 16 over 3. Now I'm going to hold off on combining this because we got to do this other one, and you might find that it's got something that cancels out or something. So we'll do that in a moment. Anything you'd like me to cover again on this? I mean, we can do another problem as well, but
No, that makes sense.
okay. So now this to find region 2, you're integrating from you're integrating from 2 to 4 now, from 2 to 4, and it's this 4 minus x squared. Now, since the area is below the x-axis, you're going to get a number here that is negative, and you have to make it positive. I could explain it in more detail about what you could do to make it positive, but I think this would be better just to say if it's below the axis and you're integrating, you convert it from positive to negative, or from negative to positive.
Okay.
And the nice thing is it's the exact same integral, so it's still, if you do it right the first time, you got it here. So it's 2 to 4. Okay. So now we're going to put these bounds in. So it's 4 times 4 minus 1/3 times 4 cubed minus big parentheses 4 times 2 minus 1/3 2 cubed. So 4 times 4 is 16 minus 4 cubed is 64. So that's 64 over 3. This is 8. So minus 8. This is 8/3 minus 8/3 becomes positive 8/3 here. Okay, so we got we actually do need to add all this up. So becomes 8 minus 56 over 3, and 8 is really 24 over 3. So this is 24 over 3 minus 56 over 3. That's minus 32 over 3. But we said you have to make it positive. Okay, so it becomes positive 32 over 3. So area one is this right here. 16 is really 48 over 3. So we'll make this 48 over 3 minus 16 over 3, which becomes 32 over 3. So area 1 is 32 over 3. That's this number. Area 2 is 32 over 3. And then you combine these together to get 64 over 3. Okay, now there is a shortcut. I think you'll like it. So if you go to your calculator and you take the integral, math 9, and you do the absolute value, so you have to get that one, that's math something to get absolute value, 4 minus x squared, and you go from -2 to 4, the entire window, this will give you 64 over 3. You may have to convert from a decimal to a fraction, but if you get these absolute values in there, you will get this answer out.
Okay, wait.
I would recommend trying that now to confirm that.
I am the absolute. Okay, so 4x or 4 minus x squared. Um, 21.333. Is that?
Okay, so if you do a math enter, it should convert that to 64 over 3.
It's not letting me convert it.
Okay, well, when you see that though, 21.33 and so on, that's your guide to say, okay, I think that's 21 1/3. Let me convert that to 64 over 3.
Okay.
So again, if you're not sure how I got that, if you go back to the original problem, you just take the function, the curve, and you use these two bounds, but you have to do it inside absolute value. If you do it inside absolute value, it'll give you the full answer right there every time. Okay. Do you want to do another one like this?
Sure.
Okay. So we're going to do bounded by the curve y equals 1 minus x squared, and the lines x equals 1, minus 1, and x equals 3. So as I mentioned before, you can go right to your calculator and you can go absolute value 1 minus x squared and do this from minus 1 to 3 dx and get a number out, and then we'll show the work to get that number.
Okay.
So do that first for me, and then we'll do the work to get the show the steps.
Okay, I got 8.
You got exactly 8?
Yeah.
Great. Okay. So now what does 1 minus x squared look like? Well, it's this upside down parabola, and it hits the axis. It's the axis here and here. Now you might be able to see that it's just minus 1 and 1, but you could set 1 minus x squared equal to 0 and then solve for x, and you would get x equals plus or minus the square root of 1, which is plus or minus 1. So that's great, but we're going from minus 1 to 3. So we got this area over here to consider. So this keeps going down, and then we got this area over here to consider. So again, there's two regions. Okay, there's this region here, we'll call that region 1, and there's this region here, we'll call that region 2. So region 1 is the integral from minus 1 to 1, and it's of 1 minus x squared dx. Is that okay? Is it clear how we get that?
Yeah.
Okay, so the antiderivative, this is x minus 1/3 x cubed, evaluated from minus 1 to 1. So now it's just a matter of putting that into the calculator, or just writing it out here enough that you convince your instructor that you know how to do this. So minus 1 minus 1/3 minus 1 cubed. Okay.
I got 0 on the calculator.
Shouldn't be 0. All right. So this is 1 minus 1/3. This becomes plus 1. And then this is negative 1 times that gives you positive 1/3, so minus 1/3. So it should be 2 minus 2/3. 2 is really 6/3, so that makes this 4/3. Probably just a sign error there.
Yeah.
Okay, so that's the area of region 1. Region 2 is the same thing as region 1 that you're integrating. It's just different bounds. So instead of going from minus 1 to 1, you're going from 1 to 3. So that's x minus 1/3 x cubed, evaluated from 1 to 3. So that's 3 minus 1/3 3 cubed minus 1 minus 1/3 1 cubed. 3 minus, and this is 27, so 3 minus 9 minus 1 minus 1/3 here. So the thing that I have to remind you of that I didn't mention earlier is that this area is going to be negative. So when we add up all of these things, the area is going to be negative. So this is negative 6 here, 1 minus 1/3 is 2/3, so minus 2/3. Negative 6 is equal to negative 18 over 3. So this becomes negative 20 over 3, but we make it positive, so it becomes positive 20 over 3. Area 1 plus area 2 is 4/3 plus 20/3, which equals 24/3, which equals 8.
Okay.
Definitely would recommend redoing this problem, or one like it, that we just did before your test. But the
Okay.
calculator thing really gives you um, a heads up here, because you can just make sure your answer matches that.
How do I know if I should do the absolute value?
Well, the truth is you can always use absolute value.
Oh,
Um, it always works. But it hides a lot of it hides this step over here on the right. So if you do the absolute value and you only show the work on the left, or you go from -1 to 3, or in the previous problem, if you go from -2 to 4, your instructor will know you don't really understand.
okay.
So that's why it's important to be able to break it up into the two pieces. Okay, 32 is integration by parts, and we'll got plenty of time to go through this topic. All right, so there's a lot that goes into integration by parts. You have to pick a U, and you have to pick a dv. And your u has to be something that you can take the derivative of, and your dv has to be something that you can integrate. But in these problems, your u is almost always going to be this thing in front of e, and your dv is always going to be this e to the minus x dx. Have you seen that in class? I hope.
Yeah.
Okay. So now we have to take the derivative of the left thing. So that's 3 dx. Okay, and this time you don't solve for dx, which is a little different than what we've been doing. On the right, you integrate both sides, so you get v equals, and this is where you got to remember the integral of e to the kx equals e to the kx over k. So your k in this case is -1. The thing in front of x is -1, so it's e to the minus x over -1, but that becomes minus e to the minus x.
Okay.
Okay, so then now to do integration by parts, this is where you need you're in the classroom. It's uv minus the integral of v du. So you have a u, you have a v, and you multiply them together. So it's your u is 3x minus 1, your v is this e to the minus x, minus the integral. You have to grab that v again, minus e to the minus x, and then there's your du, 3 dx. So it's just grabbing 1, 2, 3, 4 pieces. 1, 2, well, 3 pieces, and two of them, one of them appears twice.
Okay.
So that's like, if you can get this far, you're really in good shape. So on the left here, I'm just rewriting it. This negative combines with this negative, so make it plus. I'm going to bring the 3 in here, 3e to the minus x dx. Okay, so this integrates. Integral e to the kx dx equals e to the kx over k. So in this case, you've got a negative here. It becomes e to the minus x over -1. And then this 3 just comes with it, plus c.
Wait, I think I got lost.
Okay.
You know what? Previous step.
We're integrating this right here, e to the minus x. I know there's a 3, but the 3 could really come out here. I mean, the 3 could be there. Okay. So you're just integrating e to the kx, where in your case, your k is -1. It's a number in front of x.
Okay.
So the integral of e to the minus x is e to the minus x itself over the number that's in front of x, which is minus 1. And then you bring this 3 down, plus c.
Okay.
So this becomes, these combined, so it becomes minus 3e to the minus x plus c, and then this stuff just comes down, 3x minus 1 e to the minus x. And that's your final answer. The one in the WebAssign answer is simplified, like they factor out an e to the minus x. You don't have to do that. Yours is really close, actually. Actually, yours is like perfect. Don't know why it was marked wrong.
For number 32.
Yeah, it looks like this is correct. Yeah, I don't have a good answer for that, because this actually doesn't even look right, because when you put your, when you factor out a 3, well, yeah, I don't know. It looks UV UV. Oh, you know what? I didn't catch that. There is a negative that goes here. I didn't catch that. So there's a, your V is negative E, so there's a negative that comes here, right in there, and then that should be brought out in front.
Oh, okay.
And that affects. I mean, that just affects that here, but that's why it was marked wrong, because it's. I mean, I did it. You did it. Um, all right, let's do another one like this. I'm hesitant to give you one e to the minus x, because it's I don't know, just, but that's probably the form they're going to give you, so we'll have to do it here. Okay, so we're gonna do this one together here. U is the thing in parentheses, 2x minus 1. You take your derivative, du is 2 dx. dv is whatever is left over, so it's e to the minus x dx. And then you have to integrate both of these. So whenever you integrate e, this is where I think it was unclear. Whenever you integrate an e where it's not just a variable, you keep it, but you divide by whatever's in front of x. So your v is e minus e to the minus x.
Okay. And then you do 2x minus 1 times.
Yeah, so you do 2x minus 1 times this now, this negative. So I'm going to put the negative here, e to the minus x, minus the integral, v du. So your v is minus e to the minus x, and your du is 2 dx. And so then these two negatives come together. Two e to the minus x dx.
Okay.
All right, so now the integral of this, you can bring the 2 out if you want. It's just going to come along. Okay, so you're integrating e to the minus x dx. Just like before. I mean, it's the exact same thing as we did up here on the top right. The integral of e to the minus x is itself. Sorry, let's scroll right past this. E to the minus x, it's itself, but then you divide by whatever's in front of x, which is negative 1. That 2 comes down, and then this stuff also comes down. So it's minus 2x minus 1 times e to the minus x. And then you have a c. C comes with the integration. Negative parentheses 2x minus 1 e to the minus x minus 2 e to the minus x plus c. Oh, 33 is really similar. It's just in a different form. So we'll check that one out next.
Okay, that makes sense.
All right. So we could have just done this example because you're gonna say, oh, it's the same because it is. This integral up here can be rewritten. The integral of 2x plus 1 over e to the 8x dx. First thing I want you to see is that this can be written as 2x plus 1 times 1 over e to the 8x. And there's a property over here. If it's 1 over e to the n, or x we'll say, this equals e to the minus x. So you're gonna bring this up to the top, but you're gonna put a negative in front of it. So it becomes 2x plus 1 e to the minus 8x. So just bringing this up to the top, the whole thing, makes the exponent negative. I assume you've seen that before.
Yeah.
Okay, so now the problem is just like the one you just did. It's really 2x plus 1 e to the minus 8x dx. We've got to get a u and a dv. So u is going to be the 2x plus 1. So du is 2 dx. And your dv is e to the minus 8x dx. And then you're going to integrate both of these. So v equals e to the minus 8x, and then you divide by negative 8, whatever's in front there. So v equals negative 1 over 8 e to the minus 8x.
Okay.
Then your formula here is uv minus integral v du. Your u is 2x plus 1. Your v is this minus 1/8 e to the minus 8x minus the integral v du. So you have minus 1/8 e to the minus 8x times 2 dx. So on the left here, I'm going to bring the negative 1/8 in front. Two x plus 1 e to the minus 8x. These two negatives combine, plus 2 and 1/8 makes 1/4. So it's 1/4 e to the minus 8x dx. That's just combining signs and multiplying a little bit. The 1/4 can come out, so it becomes plus 1/4 integral e to the minus 8x dx. And again, keep in mind, you already did this. You already did this up here. You already have the answer to this. But just again, as review, when you're integrating e, you get itself divided by the thing in front of x times 1/4 plus c. And then you bring down this other stuff. So negative 1/8, 2x plus 1, e to the minus 8x plus this. And then you can simplify. So first thing doesn't simplify at all, but 1/4 and 8 on the bottom, or negative 8 on the bottom, that's negative 1 over 32 e to the minus 8x plus c.
Okay. It's a long process.
It is, and it's several things, together. Do you want another problem like this? Would you like us to go through something else? We've gone through everything I think that you sent for today.
Um, I think that's all I have. I mean, we could go through another problem, I guess.
Okay, so let me make one up here. Integral 3x plus 1 over e to the 6x dx. So give this a try. Get as far as you think you can get, and then I'll just check in with you for some steps, just to see if you're doing
Okay.
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 just going to start writing a few more things, and you can let me know if any of this is unclear.
Okay.
So your UV minus integral V du. This is kind of the big step here. That's the simplified UV minus integral V du for this integration reports.
I'm almost done with it. I just
Okay.
got stuck on the part where I'm looking back at the other one where we took negative 1/8 and then times 2 and you got 1/4. So is it 1/6 times 3?
Yes. Yep. And then the negatives cancel, so it becomes a half.
Okay. And then at the very end, we got negative 132 e to the negative 8x. No, and I'm confused where we got that.
Where we got which one? Up here?
Negative 132, yeah.
Well, we had to integrate this e to the minus 8x again. I'm sorry, we integrated e to the minus 8x and it became this. And then you multiply 4 times 8 to get the minus 32. So you still have a step down here though where you have to integrate this.
Okay.
You have to integrate this e to the minus 6x dx just like you did up above.
Okay, so that, okay. Okay, so then I got negative 1/6 times 3x plus 1 e to the negative 6x minus 1/12 e to the negative 6x plus c.
Perfect. Yeah, if you get that on the test, just check your signs, and it'll have this form though. If it's like this question or like the previous one, it'll have this form. They'll both be negative.
Okay.
Is there we probably don't have time to do like a full problem or anything like that now, but is there a concept or something else that maybe you want to?
That we can be done with the problems, but I was gonna ask, how do you do derivatives and integrations on the calculator?
You cannot do derivatives on the calculator, just the integration that I showed you.
Oh, how do you, is that just the math 9
That's
thing?
the math 9, yeah.
Okay.
And I recommend using the absolute value all the time. It'll save you on the ones where it matters. For the ones where it doesn't matter, you'll get the same answer.
Okay.
So that's it. But there are no numerical derivatives. There's no derivatives because it gives you a number, and you generally want a function for it.
Okay.
There's a lot here, but you showed me you can work through the hardest problems on this test. So if that's an indicator, you should be very well prepared for it.
Okay. Thank you.
You're welcome. I'll send you the notes and the screen recording out later today.
Okay, perfect.
Okay, bye now.